All right, awesome. So now that we know a little bit more about Chainlink automation, how it works and how we can actually set it up, we can actually use Chainlink automation to automatically kick off our lottery whenever it's time. And the Chainlink nodes will be the one to do this. To do this, we're going to need these two functions, check upkeep and perform upkeep. So right now in our code, we have this pick winner function, and we're going to revamp this so that we're kicking off our contract calls with Chainlink automation instead. So as that video went over, we first need to create a check upkeep function. And this is the function that's going to tell the Chainlink nodes when it's time to call perform upkeep. And for us, perform upkeep is going to be kicking off a Chainlink VRF call. So what we can do below our enter raffle is we can create a function called check upkeep. And this is going to take a bytes memory check data, which we're actually going to ignore and have it be blank. If a function of yours requires an input parameter, and for the Chainlink nodes to recognize this function, we need an input parameter, but you're not going to use that input parameter, you can just ignore it by wrapping it in a comment like this. So this check upkeep function, they have it in the docs as external view. We're going to have ours as a public view for reasons I'll explain later. They have theirs as an override as well because they're importing the automation compatible. We're going to ignore that because this is just an interface and we actually don't really need it. This is just to make sure that we don't forget to add the check upkeep and perform upkeep. But if you want to add it, you can add it as well. But this is going to be a public view, and it's going to return two things: a Boolean upkeep needed and a bytes memory perform data. So I'm actually going to copy this, paste that here. So it's returning whether or not an upkeep is needed. And for us, the upkeep is needed when the lottery is ready to pick a winner. And a bytes memory perform data is if there's any additional data that needs to be passed to this perform upkeep function. For us, we're just going to ignore it. So we'll go like this. And so the question for us is the check upkeep function should really just return when the winner is supposed to be picked. And we can do some nice nat spec here like this. And we can say at dev, this is the function that the Chainlink automation nodes call to see if it's time to perform and upkeep. The following should be true for this to return true. 1, the time interval has passed between raffle runs, and this is that interval that we set above. 2, the raffle is in the open state. 3, the contract has ETH, aka players. And then 4, this is implicitly, the subscription is funded with Link. And if we want, we could add the parameters, which is this check data, what it returns and everything. I'm just going to ignore those for now. So this is what we want our check upkeep to do. We want it to return this upkeep needed as true if all of these conditions are met, otherwise return false. Now, something cool about the returns piece is we can actually initialize variables in this like returns section here. So when we say returns bool, if we just did this, right, returns bool and returns bytes memory, we would have to create some Boolean variable. We would do bool some var equals true, return some var. Or if we name our variable in this return statement up here, upkeep needed, and then we'll also do this perform data like this. Instead, we can actually just leave it blank and it will automatically return whatever upkeep needed is, even without a return keyword. So we could say upkeep needed is true, and it would return upkeep needed. We say upkeep needed is false, and it would return upkeep needed because we defined it in the function up here. All right, so let's actually check all these pieces up here. All right, first one, the time interval has passed between raffle runs. We actually already did that down here. So for now, I'm actually going to copy, delete, and paste this in here, but I'm going to change this up a little bit. Instead of making this a conditional, we're going to turn this into a variable. We're going to say bool time has passed equals this stuff. So block.timestamp is less than, actually let's do greater than or equal to. So we got to do the reverse since we're saying time has passed equals block minus timestamp is greater than the interval. So if the current block stamp minus the last one is greater than the interval, then time has indeed passed. So great. So that's going to be the time interval has passed. The raffle is in open state. So we could say bool is open, and this is just going to equal raffle state dot open equals s underscore raffle state. So if the raffle is indeed open, if the raffle state is indeed open, is open will be true. We want to check that the contract has ETH, aka players. We could also check the contract has players, but let's just say bool has balance. This will be equal address this dot balance is greater than 0. We probably should check for players too. So let's check for players too. So we'll do bool has players equals s underscore players dot length is greater than 0. And then we can say upkeep needed equals whatever all of these being true is. So we could say time has passed and is open and has balance and has players. This double and sign is logical and. If any of these are false, upkeep needed will be false. So now it's going to return upkeep needed automatically. And if we had perform data named, it would return perform data. I like to be very explicit. So I like to do return upkeep needed, and we'll do a blank bytes object. And this is how we can say it's a blank bytes object. Okay, cool. So now we have a function that's actually going to check to see, hey, is it time for this lottery to get updated? And now instead of pick winner, we're going to have this be our perform upkeep function. So the Chainlink nodes are going to call this check upkeep function, but they're going to call it as a view function, right? They're not actually going to send a transaction. They're going to simulate this. And then if this is returning true, then they're going to call perform upkeep. So first, we're going to actually have to change our pick winner to perform upkeep. So I'm going to grab this here, copy, paste. So now we're going to change its name to perform upkeep. Takes a bytes call data, perform data, which we're not going to pass any perform data. Again, this is for customizing this, and we don't really need it to be super custom. So now, since this is an external, anybody can call this, right? So we want to make sure that it's actually time to call this function, right? So we can validate this a little bit. We'll first say bool upkeep needed equals check upkeep. We'll pass some blank data in here. So we're going to call this check upkeep function in our perform upkeep function to make sure it is indeed time to do an upkeep. Then we'll say if it's not time for an upkeep, then what do you think we're going to do? We sure as heck are going to revert with a new error, raffle upkeep not needed. And for our raffle upkeep not needed error, we could make it just blank like this, or we could add some debugging tips to make it more helpful for whoever runs into this error. So maybe we'll say, okay, let's give them the address. Let's give them the balance of the contract. Maybe we'll do the s players dot length, and then we'll do a uint256 s underscore raffle state. So the state of it. So now this is going to show you guys that we can actually make errors, error raffle upkeep not needed, with parameters in them. So we could do uint256 current balance, uint256 num players, and then uint256 raffle state. We can do this because we could also do raffle state, or uint256 raffle state, because again, a raffle state can directly be converted to a uint256. So we could do either one here. But okay, great. So now we have a different error, a different revert here if it's not ready. And then it's going to be the Chainlink keepers that are actually going to kick off the Chainlink VRF call for us. And you know what, let's just delete this for now, but we might add it back in later. Cool, and let's actually get rid of some of these warnings. We don't need the request ID, so we'll just block that off. Cool, and stuff's looking pretty good. Let's try to compile this. Forge compile or forge build. And awesome, it compiled. Our code's looking fantastic.